Hi. Not entirely sure how I can follow that little chat, but I'll try. I'll apologise in advance for my slides. I put some together and they're very bland, so I gave them to our marketing department and they over-marketed them, so I've tried to pull it back a bit, but I might have to skip over some of the gloss. Inert Networks is a triple play provider in the UK. We're just starting our third academic year of delivering IPTV to student accommodation, sort of dorm rooms at universities. And it's going very well. One of the what we found was that a lot of universities were needing to do something about TV. Dorm rooms in the UK certainly don't have satellite TV, they don't have cable TV, they depend on over-the-air broadcasts. And in the UK, much as I believe it is in the US, we're going through the analog to digital switchover. At the moment, students take TVs into their dorm rooms and stick a little aerial on top of the TV and get a fairly snowy analog picture, which is great when it's analog. When you go to digital, then you're going to get nothing. So universities recognised they needed to do something. A few universities went off on their own and started to put together little mini IPTV setups, typically based around VLC or something like that. Once the broadcasters cottoned onto this, they started clamping down on rebroadcast rights and things like that. So that's where NANOG came along. We spent a lot of time talking to broadcasters and negotiating all the rights to be able to deliver content to students, but then we needed technology to do it. Just a bit about the student market to give us some scope. There's about just over 3 million students in the UK. About 500,000 of those actually live on campus, so we've got quite a large audience. Talked about digital already. Universities are trying to clamp down on streaming media. They're very worried about the huge growth in unicast traffic. In the UK, BBC, the main broadcaster, has a product called iPlayer, sort of catch-up TV, download and streaming. The other broadcasters are doing something similar. Universities are very worried about their network bandwidth, and they're actually putting clauses in some of the sort of T's and C's of the ResNet network connections that say things like the one I've highlighted here. You are not permitted to download or stream films, movies, television programs or video clips, including BBC iPlayer for on-demand, YouTube, etc. So students want to get TV, but the universities don't want to kill their network in the process. So we came along with an IPTV solution, one centralised head end, so there was no capex for the universities, delivering that over multicast into the universities and wrapping that up with the middleware and other bits that are needed to make it work. From our IPTV head end in London, we're delivering both into Janet and also into Cable and Wireless. They're probably in the top 3 DSL providers in the UK, but the only one that is delivering multicast over DSL. So that gave us an opportunity to deliver services not only to on-campus accommodation, but also those that have moved out of dorms into private accommodation. We've tried to replicate the digital TV setup as closely as possible. Full-frame D1 broadcast quality video, H.264 encoded, 2 megabit per second. Got about 112 channels worth of that leaving our head end. Also needing to use conditional access, but rather than using Microsoft or other proprietary DRM solutions, we used the same conditional access technologies that digital TV uses with ECMs, EMMs in the MPEG transport stream. But because we're on IP, we had the opportunity to use IP for key distribution for that, so utilise some of the benefits of that. Here's one of the marketing slides. I'm going to skim very quickly over that. That's showing that we had to build quite a large back-end system to support all this as well. And so we got this. Looks very much like you would your TV system at home, full screen video, on-screen EPG. But you might notice it's on a PC. What we found was that student rooms are getting smaller, students are getting bigger. They didn't want to bring both a PC and a TV on campus, and certainly in the early days, talking to universities, they almost wanted to discourage the students from bringing TVs because they had to provide more power sockets in the rooms, more electrical safety testing to be done, and all the rest. So universities encouraged us to go down the PC route. So we developed a solution, what we call a virtual set-top box, which we pretty much emulate a set-top box on a PC. In fact, it's been developed so that to middleware systems, so the server side of IPTV, they can pretty much not tell the difference between whether they're delivering to PC or to a traditional set-top box, Motorola or something, Atlanta, etc. One of the key benefits of this is that for those universities, and we're working with some universities that deal with the sort of more upper-class student, for want of a better term, would rather have a big flat-screen TV in their room with set-top box. But that means that we can deliver the same solution to both the set-top box and to the PC with no changes in our head end. So on to slightly more interesting bits, how we actually do this. All the universities in the UK are connected together onto a network called JANET, the Joint Academic Network. They operate a 40 gig ring around the UK. On the diagram, that's the fat red lines. Links 8 core POPs around the UK. And then from those core POPs, they hand the traffic off to regional network operators, which there's 19 around the UK, and they're resiliently connected to JANET. And then universities will connect into their closest regional network operator. We've interconnected in with JANET at London, and that allows us to deliver both multicast and unicast out to all the universities. Of course, we had a few challenges along the way. Some universities, they're very familiar with multicast already, and for those, it just worked. You go to a lot of, listen to a lot of talks about IPTV, I read a lot of white papers, particularly from router vendors that want you to buy all their kit, and say that it's exceptionally hard to do IPTV, and you've got to invest heavily in latest and greatest hardware and all their special tweaks to make IPTV just work. What we found was you don't need any of that. As long as multicast gets from A to B, then it works. Of course, we did have quite a few problems. Universities that weren't familiar with multicast, those that were but kind of knew how to do it on campus but didn't know how to get it in from the outside world, and we had to work with them. In most cases it was easy. You bring up your MSDPs, you bring up your PIM adjacencies, and it works, except they all put firewalls in the way. What we found was, whilst router vendors, have got multicast sorted now, and it's just a switch to turn it on. Firewall vendors, not quite the same. I think we had one particular problem with Checkpoint. I'm not entirely sure that they've actually fixed it yet, where if it was running in layer 2 mode, yeah, it could. You could configure an ACL to allow multicast to go through, but you turn it into a layer 3 mode, and PIM, what's that? So what we found was that a lot of universities were having to build little bypasses around their firewalls to allow multicast in, which works, GRE tunnels or just a cable around the outside. The other problem we found was that universities, in response to the problem with streaming traffic, peer-to-peer traffic, are putting a lot of packet shaping and bandwidth management tools in, with the sole purpose of limiting the amount of bandwidth that their students can get to from their dorm rooms. Except we want to deliver 2 megabit streams to them. So we quite often found that the packet shapers would rate limit this nice 2 meg stream because that must be bad, down to 128k, and hey, TV stops working. And QoS. Again, it's one of those big things that router vendors will tell you that you've got to have because, hey, they've got a solution for fixing that. Certainly on Janet and the regional networks, they use the easy fix to QoS, which is over provision. Janet, 40 gig backbone, the regional networks, multi-gig networks, no congestion, TV just gets through it fine. However, once you get onto the campus, they find that there's a lot less money available. Links from central campus out to the dorms might be on 100 meg link or maybe a gig if you're lucky, and they're heavily contended. So we found that we had to work with some of the universities, certainly with the smaller residential networks, to implement local QoS on campus, marking our traffic, prioritising. And of course, as is always the case when you don't control the network from end to end, there was an awful lot of finger pointing. We'd be contracted with the university to deliver an IPTV service, so when it breaks they phone us up and say, hey, it's broken. So we have a look and we see that the university is not actually receiving any multicast, so they escalate it to the regional network operator. Regional network operator being stuck between Janet and the university, we had no responsibility to, they had no responsibility to us. So when the university phoned them up and said, hey, it's broken, they said, no, it must be Nook's fault, must be Janet's fault. So we go off and we talk to Janet and say, hey, those guys over there say that you're not giving them any multicast, and Janet say, yes we are, look, it's going there. So we go back to the university, we go back to the regional network operator, and the problem typically magically goes away. No one admits that they broke anything, no one admits they ever fixed anything, but one of the things we learned very quickly was that we needed to have a lot better visibility into what was going on. Unicast, you kind of push it out and you hope it gets there. So what we had to do was deploy a number of remote multicast monitoring nodes into universities, which were able to detect and analyse the incoming multicast streams to validate that they were being received properly. By deploying multiple monitoring nodes on one regional network, we could soon see patterns whereby if all the monitoring nodes on one regional network went down, but all the other regional network monitoring nodes stayed up, then there was a good possibility that it was that regional network operator that was at fault, and that helped us with the finger pointing in their direction. Allowed us to provide just basic availability graphs, as you can see there. And it's worked well. Looking at some of the reported viewing stats in terms of minutes per week that the average user consumes of TV. Web TV providers, internet TV providers, the Zatus of this world, are claiming low 100 minutes per week per user. At the other end of the spectrum, traditional TV in the UK, that's reported on by an organisation called Barb, is reporting about 1,500 minutes per week per user. and we're just over 1,000. So what we're seeing is that if you take that step from web TV, the streaming, which is typically low bit rate, to get it down pretty much any line, typically small frame size, up to a full digital TV experience at a higher bit rate, then users are more willing to actually watch that. And maybe it's just because we've got friends and they haven't. Friends of the program, not friends of people. Of course, as I say, multicast is unidirectional, so we throw it out there, but how do we know that people are watching it? But it's IPTV, it's IP, we've got a back channel. All of the clients report back to the IPTV middleware, the central server in our head end that provides all their metadata and EPG information about channel changes. And so from that we're able to construct usage figures, anonymized, about who's watching what and when, and allows us to produce some fairly accurate graphs. As you can see, there's one of our channels there, and there's a nice peak around 6 p.m. So there's obviously a popular program on then. But the broadcasters love this. In the traditional world, they are used to getting their audience figures by doing sampled surveys. 1 in 1,000 users, they'd give them a little logbook and say, write down what you watched today. But now we're able to say to them, you put this program on at 6 p.m. and by 6:03 you had this many people, and then the commercial break came in 20 minutes later and everyone switched off. So they can tailor their broadcasting accordingly. But equally the advertisers like this as well, because they know pretty much to the user and to the second how much people are watching their adverts. Again, we can go to them and say, as soon as that advert for Ford cars came on, everyone switched off. So you probably don't want to run that one again. Which led on to one of the key revenue opportunities for us in IPTV, which is advertising. What we've found is that advertisers are very keen that they can now have an addressable audience. We know who each of the users is. We've got information about them. We can capture their viewing figures, their viewing habits, and things like that, which allows us to do targeted advertising. We're running a trial on that at the moment in the UK with Channel 4, one of the main TV channels in the UK. And we are replacing their ads with student-targeted advertising. At the moment, we're just providing one replacement for students because it was an easy demographic to sell to them. And advertisers like that, and the brands like that. Of course, the way we're doing targeted advertising at the moment is that in our head end, we're taking the Channel 4 stream and putting it through an ad splicer and producing different versions of it, which kind of negates the benefits of doing multicast, because suddenly you want to be able to address your audience. You may want to split them down into 100 different demographics. You might want humanities students, male students, female students, students that like watching Top Gear or The Office or something like that. And suddenly, rather than one copy of Channel 4, you've now got 100 copies of Channel 4 leaving the head end. So what we're currently investigating is trickle feeding of advertising down to the student edge, into the viewing device, the PC typically, and pushing the ad splicing capabilities right out to the edge, which gives us unique opportunities to, at the far end of the spectrum, give every user a different advert in the commercial break. There's just a marketing slide about how we do that. It's a slightly different arena in ad replacement in the UK. Out in the US, you have a lot of your regional broadcasters and regional cable codes that will do ad replacement. So the broadcasters are used to tagging where their ad breaks are and allowing for them to be replaced. In the UK, we don't have that. Channel 4, as the example we're using, send out one copy of Channel 4 and they expect that to be seen by everyone. And in fact, they don't want to tag where the ad breaks are, because the clever people then go and stick a box on the end that rip all the ads out and save it to disk. So we've had to work with the broadcasters to actually put that capability back in, to tag where the ad breaks are, and then gives us the opportunity to replace them. Of course, linear TV, which is the majority of what we're doing at the moment, isn't the be-all and end-all. People are getting a lot more used to the I want to decide what I want to watch and when I want to watch it, which moves us into VOD. But we're moving away from that, moves you back away from multicast into unicast, which is not what the universities want. Traditional VOD in IPTV world, you go out to Sun and they'll sell you a big VOD server that fills 3-4 cabinets and can deliver 100,000 streams from your head end, and hey, the network is somebody else's problem. That doesn't really work for us. So we've gone out and we've found a vendor that actually can provide this little 1U box that you can see on the screen here. Can deliver 20 gigabits per second of streaming from up to 4 terabytes of flash storage in that box, in a 1U thing at low cost, which has completely changed the economics of doing VOD, because we can now start to spray these around the edge of the network. With students, we can push them into every university if need be. In DSLAMs, then we can push them out to exchanges, to central offices, to serve from as close to the edge as possible. And of course, IPTV isn't just about watching IPTV. If you listen to Dr. Vincerf's talk yesterday, he was saying that IPTV is more about integrating in with other stuff, and it's not just sitting down and watching TV. So of course, we're in an IP world, so we've integrated in with Facebook, as everyone does. So we have some widgets on Facebook where you can go and, if you're a FreeWire user, our TV brand, you can go and go onto Facebook and you can see what your other friends are watching on TV at the moment. You can build communities of people that like watching Friends or so on. Also in the IP world, has allowed us to work with advertisers to provide click-through advertising from TV, which they're not used to. One of the key prime examples, very similar to the one that Vincerf used yesterday, was you're watching an advert for a car or for music, and you can click on it because you're on a PC, you've got a mouse, and it can straight away say, hey, you're interested in that car, do you want me to get someone from the local garage to give you a call on your IPTV, on your voice VoIP handset that's part of our network as well, so we know where you are already. Or maybe you're watching a music channel and you find a track you like, you can click on it or something, and it says, hey, if you like this, then do you want me to go to Amazon and get them to send you that CD straight away, or maybe go to iTunes and download it. And of course, UK is small, so we thought we'd bring it out to the US as well, bring this more relevant to NANOG. As you're aware, the Internet 2 full conference is on at the moment in New Orleans, and we're demonstrating there what we've done in the UK, but in the US as well. So just last week I was building a mini head end in Texas A&M University, which we're delivering over Internet 2 in much the same way that we do in Janet in the UK to the Internet 2 conference in New Orleans, but in much the same way as it could be delivered to any dorm room of any university that's connected to Internet 2. That's it. Some contact details there if you're interested. If you want to see a demo of it working, I will try and get it working if you want to come and see me afterwards. But just to give you a little flavour and to prove that it does actually work, I was also given where is it? Make this work. So there's no sound, I'm afraid, but there's just showing that students in campus accommodation are watching our TV service on their PC in much the way that you would a TV. Any questions?
Hi, Alain Durand. Do you stream this multicast to the laptop over Wi-Fi?
The simple answer is no. Multicast over Wi-Fi doesn't work very well. Wi-Fi treats multicast as broadcast, and so will transmit it at the lowest common rate, which in many cases is 1 meg. And given that our streams are 2 meg, then they just don't work over multicast. There are a few technologies that are coming out at the moment. 802.11n and Ruckus have also got a slightly proprietary system that deal a lot better with multicast. But for the moment, we say that we only support it over wired connections.
And have you been thinking about adapting a multicast to unicast just close to the wireless network so Wi-Fi user could use it?
That's one of the things we've been looking at. For our DSL offering, we're using Thomson CPE equipment, and we've been working with them to see what we can do to get our TV signal to go over wireless, and translating at the CPE from multicast into unicast is one of the options that they're working on at the moment.
Thank you.
Other questions? All right.
Thank you.
Thank you very much.